You assume AI reasons because it sounds coherent. By the end of this, you will understand why that assumption quietly fails under pressure. AI does not think in the way the word reason implies. It produces sequences that resemble reasoning because those sequences appear often in its training data. That resemblance is persuasive. It feels close enough to trust. But closeness is not equivalence. Reasoning is not the act of generating an answer. It is the act of constraining an answer by reality, consistency, and consequence. Humans do this imperfectly, but they do it causally. They track what must remain true, even when language changes. AI does not track what must remain true. It tracks what usually follows. When an AI responds, it is not asking whether a statement is justified. It is asking whether a statement is statistically appropriate given the prior text. This distinction is subtle in normal conversation. It becomes obvious when conditions shift. Reliable reasoning requires a stable internal model of the world, not a description of the world, a model that resists contradiction, a structure that can be wrong and know it is wrong. AI has descriptions. It does not have resistance. If you give it a premise that contradicts earlier information, it does not experience conflict. It experiences a new context. Both can sound equally confident. This is not a bug, it is the design. Large language models are trained to minimize surprise, not to preserve truth. They are rewarded for producing outputs that humans recognize as acceptable continuations. Truth matters only insofar as it correlates with acceptance. This is why AI can argue convincingly for opposing positions with equal fluency. It is not weighing them. It is selecting them. Reasoning, when it works, eliminates possibilities. AI expands them. When humans reason, they narrow a space of options based on constraints. When AI generates, it samples from a space based on likelihood. The direction is reversed. This difference hides well because language is a forgiving interface. You can say many wrong things and still sound precise. You can be inconsistent and still sound coherent. AI exploits this tolerance naturally, not intentionally, mechanically. Consider how AI handles edge cases. The moment a situation departs from common patterns, confidence decays. Not gradually, abruptly. It may still sound calm, but the internal process has lost its footing. This is why AI performs well on benchmarks, yet fails unexpectedly in real systems. Benchmarks reward pattern completion. Reality punishes assumption. Reliable reasoning requires the ability to notice when the rules no longer apply. AI does not notice, it adapts. Adaptation sounds intelligent, but without grounding, adaptation is drift. Another failure point is justification. When humans reason, they can explain why a step follows. That explanation is anchored in constraints they recognize. AI can explain steps, but the explanation is another generated sequence. It is not bound to the same internal necessity. This is why explanations can change without the answer changing, and why answers can change without explanations changing. The system does not experience commitment. It does not hold a belief long enough to defend it against pressure. Reliability depends on commitment. There is also no internal check for contradiction unless explicitly prompted. If two incompatible statements are both locally plausible, both can appear. Humans experience contradiction as discomfort. AI experiences it as parallel possibility. This matters because reasoning is not just producing an output, it is maintaining coherence over time. AI has no time, only tokens. Each response is a fresh calculation, conditioned on text, not on belief. Memory is simulated, not inhabited. You may think this is an abstract concern. It is not. As AI systems are placed into decision-making roles, their failure modes become structural. They do not fail loudly. They fail politely. They give answers that are almost right, almost justified, almost aligned. Those are the most dangerous answers. A calculator that gives wrong results is quickly abandoned. A system that gives plausible but unreliable reasoning becomes trusted. The more fluent it becomes, the harder it is to notice when it is drifting. This creates a paradox. Improving surface intelligence can reduce epistemic safety because confidence increases faster than constraint. Engineers try to patch this with rules, verifiers, and external checks. These help, but they sit outside the core process. The core remains unchanged. AI does not know what it is saying, not in the philosophical sense. In the operational sense, meaning is not represented, only correlation. This does not make AI useless. It makes it specific. It is powerful where patterns are stable. It is unreliable where novelty matters. Human reasoning is weak, but grounded. AI reasoning is broad, but ungrounded. When both agree, the result feels magical. When they diverge, the divergence is silent. The real risk is not that AI will think incorrectly. It is that we will mistake fluency for constraint. Once that mistake is normalized, systems are built on it. Decisions inherit it. Errors compound invisibly. You should care because reliability is not about average performance. It is about behavior under pressure. AI has no concept of pressure, only probability mass. As long as we remember this, AI remains a tool. When we forget, it becomes an authority without accountability. And authority that cannot reason is not obviously dangerous. It is quietly so, because it will never tell you when it does not understand.